Okay, so this talks about AWS temporary tokens or credentials. So it's all about default security models in AWS and what we can do about them and the security challenges. It's not a product pitch. When a product pitch, the expo floor is that way. And we're gonna really hopefully dig into some relevant information for you. So not too much about me. Nikhil introduced me. This is my day job. These are some of the things I've worked in, mostly product and engineering roles. And then on the side, if security bores you, we can talk about sending science experiments to space for kids. I just like that video because it's sort of the Neil Armstrong moment of floating bits in free fall. That's the ISS, the space station. Someone woke up and said, "Did you say ISS?" No, this is about AWS. So let's jump into it, right? So what we're going to do is talk about an attack scenario in AWS that leverages temporary tokens. If you don't know about that, we'll switch to the defender viewpoint and see what difference that makes if you're exploited or can be exploited by that. And then we'll summarize some takeaways. What can we do about that, okay? So really this is about 50 minutes of content compressed into 25. So if I talk fast, that's the reason. But really you guys gotta listen twice as fast, right? So crank up, all right? No post-lunch siestas here, all right? Think fast, think hard. So here's the basic scenario, right? We're basically talking about an S3 bucket access, right? I'm gonna start with a compromised key. I'm gonna generate a temporary token, and we'll talk about that, but it's essentially a copy of my access key that was compromised. And I'll keep that in the back pocket, maybe for backdoor access. And then I'm gonna escalate privileges using the stolen compromised key. And through that escalation of privileges, I'm gonna go after an S3 bucket. Pretty basic, pretty straightforward, but hopefully common enough that you can apply it to other scenarios, right? Just a few weeks ago, we had a credit financial institution that had PII, credit information on S3 bucket, right? So I think it's pretty relevant. So let's start at the beginning. Compromised keys or access keys. Let's assume I go to Pastebin, do a search, find an access key. I think that's reasonably realistic. Could be on Gist. One of your developers might have checked it in and uploaded it to GitHub. Or we could go old school, and maybe I compromise your endpoint and steal your credentials that are just in a credentials file because you use the AWS command line, right? So I think it's pretty reasonable nowadays that you can have credentials compromised, right? And from the command line, so bear with me for those folks familiar, I'm gonna use the command line to demonstrate things, but this could easily be the API of AWS, right? And so let's just say I have a key and a secret, right, up there on the screen. Those are my compromised credentials. So the next step is I'm gonna generate temporary tokens, and then we're gonna get into the details of what that is and what it means, all right? So the way I do that is another API call or command line, right? And there's a get session token call. It's in the STS service. I pass in an expiration time. These are temporary. They have a timeline, a lifespan. It's 900 seconds. That's the minimum, 15 minutes. It can be up to 36 hours, a day and a half, that have an extra set of credentials. Okay, and what do I get back? If you can see that, I get something that looks like a permanent API or access key. I get another ID that's generated for me, another secret or password. I also get a session token and the expiration date. The session token has to be passed in future API calls. Question you should ask is, why is there a session token? It doesn't really seem to be useful. It's another piece of information. Anytime there's things like that, as a security professional, you just want to say, hey, extra stuff, extraneous stuff, not good, causes confusion, it's an opportunity for misconfiguration. But let's keep going, okay? So now that I've got two credentials, one compromised, one I generated myself that's essentially a copy, I probably look to do discovery, right? I've got my red hat on, I'm the attacker. I'm not sure what I can do, and that's my next job. So I put a bunch of command line options. In reality, this might be Python code doing API calls. In reality, it might just be a tool that's freely available that does some exploration and discovery. I might want to find things like, what other users, what account am I under, what user am I under, what groups and permissions do I have access to with these keys? And then if I spot something juicy or interesting, I'll go after it. All right, so imagine I execute a bunch of these commands, I process it, and I look at the results, which is just JSON. What do I see? Starting at the top, well, it's useful to know what account, AWS account, these credentials belong to. And just a little side tangent, in case you don't know, IAM went through some changes, which you probably would only know if you monitor the document history of the IAM service on Amazon's pages. That's the URL there. And if you do, you see on July 24th, which is 6 weeks ago, that a new API call was introduced that was get access key info. It's really cool. You can pass it a temporary key, a permanent key. It doesn't have to be your key. It can be from another account, and it'll return you the account number. You salivate if you're an attacker, and you worry if you're a defender, because discovery is sort of the starting point, right, for doing bad things, because you pass that to other API calls. I can find the user, right? I can do a different, oh, it's Jenko temp user. That sounds sketchy already, right? No groups with this user. Are there any other users? So I keep going. What else can I get from my discovery? I find that there's an attached policy, which ultimately is going to tell me what permissions this user can actually do. It can assume role, which is AWS's version of escalating privileges. Well, what role is this? Something called Jenko bucket role. That's even sketchier name, but it hints at something interesting, a bucket access maybe. And if I keep going, I see that the actual policy with that role that I can get to, or assume, can perform at the bottom any action on a bucket called Jenko bucket 6. Any action, S3:*. All right, so let's step back. Is this realistic? I think it is. Like, imagine this is a support admin who lost their credentials, and that support admin's job is to, from time to time, administer a bucket, do things. They might have complete privileges over that bucket. I think it's reasonable. And they assume that role when they need to do it, otherwise they go on their merry way. Okay, you might argue it's a little bit broad to do S3:*, any action. That's fair. But I also say this is probably pretty common. So then what happens? Well, if you followed that discovery chain, this picture tries to capture what I just said that was in all that JSON, which can be very confusing. Basically, there's a compromised key, I'll call it A, which I got off Pastebin, actually belonged to Jenko temp user, who was really sloppy with it, apparently. And that key and that user can assume a role which has ultimately access to a S3 bucket, where generally I'll find interesting data, or might. Now, before we go through all this trouble, attacker will be like, well, before I escalate privileges and do an exploit, maybe the compromised key can directly go to the bucket, right? So maybe I check that right off, right? I had that compromised key, I set my environment variables to the key and the secret, and I can just do an AWS command line to see if I can go directly at that bucket, because I know the name of that bucket now. It's Jenko bucket 6. Well, in this case, no, I can't access it. So now I'll go to try to escalate privileges, because that's what the information I gathered says I might be able to do. So I have a picture in the main pane that is more tactically what you have to do to escalate privileges. And I want to point something out. Logically, the top right helps me understand what I discovered in the relationships of how I can escalate privileges as an attacker. But the main pane is more tactically what the API calls I have to deal with. Why is this important? Because if you're defending against this, you have to defend the main pane. You have to get down to the API calls and permissions and block it. But that's really confusing, right? And logically, you really want to understand what the relationships are at a high level. Anytime there's a disconnect between understanding the concepts and tactically executing the steps, it's more room for misconfiguration or mishaps if you're on the defending side. It's more opportunity for the red team. So what do I have to do to actually escalate privileges? I have my stolen access key. I do an assume role API call. I get back temporary tokens. Whether you want them or not, they're generated for you anytime someone assumes role. It's here and today, you have to live with it. I will use those new temporary tokens on future API calls, like the S3 bucket access. And when I use those, it will have this different role, okay? So that's the basic idea. What's it look like when I actually tactically carry out commands? This is a command line. I can execute an AWS STS assume role. I specify the role I want, which I discovered. This is this Jenko bucket role. I give it an expiration time. I put 900 seconds, 15 minutes, which is the minimum. In reality, if I was an attacker, I'd do the maximum, 36 hours. Give me the longest stretch of time, all right? And what I get back in the top half of the screen, you'll see familiar things that look like a permanent access key. There's an ID, there's a secret, and then there's a session token, and then there's expiration. It's exactly like when I did get session token earlier for my backdoor set of credentials. Already, we've encountered two types of temporary credentials. One, I said, give me a copy with get session token. I got another one when I assumed role and escalated privileges. So now I'll set my environment variables to this new one, because this new set of credentials has this higher role that's going to get me to the bucket, right? So I set that. And now I can do data exfil, right? The gold mine of what I believe is available is I should be able to now access the bucket. Now that I've switched credentials to those temporary tokens, boom, I do the same S3 call, and now instead of an error, I get the listing, right? And we all know autocommand.txt probably has credit card information in it, right? The point is, now I can access the bucket, whereas before I couldn't, all right? So what have we covered so far? We've covered the exploit. Nothing new necessary. Temporary tokens are in there, but we don't know really what the impact is. Let's switch to the defender's viewpoint. This will be more illuminating, okay? So let's talk about a few things. Put on your blue hat or your day job if you're defending your cloud infrastructure. Let's not make this too easy and too contrived. Let's assume you have AWS experience. Let's assume you have logging in place with CloudTrail. Let's assume that you have alarms in place, whether it's CloudWatch or your SIEM. Okay, you are not new to this. But you might have a little gap in knowledge about temporary tokens, and that's why you're here, right? So we can share and discuss. So what's your starting point? What wakes you up in the night? Two things maybe. Either someone from the outside says, whoa, Joe or Sue, you sort of see information that looks like your data. And hopefully you're not one of those customers that has a publicized breach. Let's just say it's internal. You set things up right, you get an event, an alarm, okay? I think that's pretty reasonable. So let's talk about detecting temporary tokens and their usage, right? Because they were used to get to your data. There might be three areas in this attack chain. When you look at the picture again, the same picture that we've just exploited, I might say that you might detect the data exfiltration side. Why? Because data exfiltration might be going to a new destination that's not normally done by that admin. They might check on the bucket, they might administer it, but they certainly don't copy everything to some unknown IP address or something like that. I think that's reasonable. Would you detect the privilege escalation, which is going back to step 3? I would say in the scenario I painted, probably not, because this admin was supposed to be able to assume role and escalate privileges to do his or her day job. And on top of this, you might have some behavioral analysis correlation that says, look, I wasn't looking for anything specific, but something happened and it looked weird, a different sort of anomaly. All right, I think those are all fair. And what I'm painting for you is that you probably have a reasonable chance of detecting something suspicious and you're woken up in the middle of the night. So then what happens? You start to investigate, right? And really, let's just say you in some way mitigate the bucket access. Now you're trying to find the root cause and shut off all of the avenues and paths that sort of led to the scenario. So you quickly get to step 3 and you're like, okay, who actually escalated privileges? And what you quickly see in CloudTrail, for those of you who haven't seen this, here's a CloudTrail event, and I've highlighted interesting things. You see access key A, which is the stolen credential I used originally. You see it assume role, and you see the temporary credential. Here's where you're at as a defender. You're like, I see the user. It's Jenko temp user. That was always a sketchy user. I said, don't hire them, and they did, right? You've got a starting point in your investigation. So what do? You probably check the role. Is it too broad? No, it's okay. It's supposed to be part of his day job. Maybe you ultimately talk to the user, verify that was a compromise and not a malicious sort of insider job. Okay, that's probably realistic. He was careless. He wasn't really trying to do things. Someone else actually used his key. So now you have to mitigate the issue, right? You're in the middle of an incident. What do? Delete the access key A, the lost, stolen one. That's probably reasonable. You might change the key, rotate it. You might change their console password, so that just in case, who knows what else has been compromised. And you definitely talk to the user and put them through training and do whatever, right? Make sure that's taken care of. And in the console, but also the API, you can do that. I can change or disable or remove the console password. At the bottom, I see the permanent lost access key. I can make it inactive or I can delete it. And I can also create a new one. Great. Standard practice on the defensive side. So far, not too much of a surprise. Here's where it starts to get interesting, because you're no dummy if you play along with me. You keep looking at the logs, and you start to see more temporary tokens. You saw the assume role earlier. You're like, oh, I see assume role all the time. I didn't pay attention to the details. Now you see get session token. When did that happen? As an attacker, it's the first thing I did with my stolen credential. I made a copy with get session token. And now you see it in the logs. And now, after you just told your boss, hey, we've gotten taken care of, we changed the lost compromised key, Now you have to call the boss back and say, whoa, there might be more credentials that were created. And as you read up on temporary credentials, here's where it gets more difficult. It seems like you have essentially API keys floating around, and this was explicitly created by the attacker. Okay, and so what do we know about temporary tokens? Let's pause for a minute. They can last from 15 minutes to 36 hours max. A day and a half is an eternity, all right? Because normally when you hear this about the incident in CloudTrail, you're already at least 20 minutes behind the curve, right? Because there's latency. Amazon's SLA is 20 minutes at least to get from an API call to having it logged in the bucket for CloudTrail. Depending on what you use for the actual alarm, your SIM or CloudWatch, it could be 30 minutes. Even if you're on top of things, you're already behind. You don't know what happened in the last 20 or 30 minutes until you go look through the logs. Temporary tokens can be generated by the attacker, which I did. I did it by assuming role, and I also created a copy early on. But AWS does it for you, because anytime an assume role happens, you get temporary tokens. If you start up an EC2 instance, there's a role that it assumes, and you will get temporary tokens. Same with Lambdas, same with dozens of other services. Okay, so it's here, you can't avoid it. Only question is, what do you do about it? All right, functionally, what are their limitations? It's 99% like a permanent access key. Of course, it expires. You can not create more temporary tokens with temporary tokens, so it's not as horrible as you might think. Someone can't keep generating temporary tokens with temporary tokens forever. But you can assume role with them. So if you have any gaps and loopholes, they can escape and get an elevated privilege and then generate more temporary tokens, all right? And for those who think maybe escalation privileges is locked down pretty tightly, I would probably beg to differ. Follow Rhino Security, they're just one of several. They have always published a list of AWS exploits to escalate privileges, right? And I have a listing later on, right? So, what else about temporary tokens? They're unmanaged. There is no central listing of outstanding, active, or historically generated temporary tokens. There's no database. There's no API called to list temporary tokens. You're almost blind. Not completely, because you can go to CloudTrail and see the trail, the breadcrumbs, but you don't have a good way of saying, hey, I've got these 3 active temporary tokens. I don't know about you, that makes me queasy when I hear about things like that. You're flying mostly blind. Logging, they are logged. You do have some trail there. So let's revisit the defensive steps we took now that we're a little bit more enlightened about temp tokens. How about detection? Good news. You can detect both the creation and usage of temporary tokens. For creation, there are 2 actions, get session token and assume role. We did both in our scenario. You can look for those in CloudWatch or your SIM. There's a problem though. Assume role is super noisy. You're gonna have false positives. You're gonna have 1 million of them because every time you run an instance, execute a Lambda, go to DynamoDB, so on, glue, blah, blah, you'll get that in your trail. So you will probably not do anything with that, but you have a trail for forensics, not so good for detection. What about usage when someone actually uses it later? If you look at this white screen, which is JSON output, I'll apologize, there's no attribute that shouts, this is a temporary token, this access key. However, if you look at the documentation, and it took me about 2 weeks to find this, but the URL's there, thank you, you're welcome. You're getting your money's worth, don't forget that. I'm saving you some search time. You find that there's a naming convention, and if it begins with ASIA, if the access key begins with ASIA, it is temporary. If it begins with AKIA, it is permanent. That's your hint from a detection perspective. Not bad though. I at least have information and I can understand it. However, if you're in the middle of an incident, you really got to fix problems. So let's talk about mitigation and remediation. All right, you cannot delete temporary tokens directly. You cannot revoke them, you cannot cancel them. That's the bad news, okay? Now what does AWS say about it? Well, 2 things. Here's how you deal with compromised temporary tokens. You restrict the role that those tokens sort of assume, or you delete the user that owns them. If you delete the user, it will invalidate any temporary tokens. Jenko temp user was the user in this case. If I blow it away, any temporary tokens will no longer work. I could take the role or permissions of Jenko temp user and also restrict it down to nothing. They're just different sides of the same coin. Think about that. If you're an organization with one admin, you might feel fine blowing away Jenko temp user. If you're a big AWS environment with dozens, if not more accounts, cross-account access, many regions, that may be a problem. At a minimum, you have to think about that. If it's not even users that we're talking about, but automated scripts using these API keys, and somehow they got compromised, you probably have application or business impact, and you have to think it through. So really, step 3 is, this leads you to, whatever the case may be, you have to look at your remediation playbook and determine whether it's still valid in light of temporary tokens. Because your remediation option is to blow away users or restrict the role basically to nothing, to contain the issue when they're compromised, right? You're in the middle of an incident. Forget it. You haven't prevented it. You've got temporary tokens floating around. That's not so good news. Now, the good news, I'm here to give you good news too, it's not all dire, is if the temporary token came from assuming role, this escalation of privileges, you do have more at your disposal. Number 4, you can revoke the session of that temporary token. What does that mean? It's the mysterious 5th tab in the role in IAM. What this means is when you press that red button, it doesn't actually cancel the token, but it puts in place a policy. And if you can see it, it says deny everything, all actions, if that token was created before this time. And when you press the red button, it takes the current time. So you're in the middle of an incident. Attacker in the past has already generated tokens, but you can put in place a policy to say old tokens no longer work. It's like having an API kind of protection policy. I'm not going to pick bones. It works for the moment until they generate new temporary tokens, which of course will have a timestamp after this. And then you're in whack-a-mole. You're going to come back and you hit the big red button, and then if the attacker still has access to your environment with the compromised key, they're going to go create some new ones. Doesn't solve the problem, mitigates it for the moment. Whack-a-mole. But it's better than nothing. I'm here to give you good news. Hang on to that, right? Okay. Let's keep going. Let's just say you get through mitigating the incident, and now you're thinking long-term. Boss, I took care of the temporary tokens, but I'm going to prevent it from ever happening again. Bad news. You cannot prevent the get session token call. There are 2 ways to generate temporary tokens. I did both, get session token and assuming a role. You cannot prevent the first case, the one where I just made a copy. And it's documented, if you ever want to know why. It's because it's considered by design, it's a feature, by design, it's an authentication step. And you can't prevent a user from authenticating. It's specifically designed for MFA access. If you have a policy that says API calls require MFA, well, you can use get session token, pass in MFA stuff, and get some tokens. Problem is it can be used without MFA. It can just be used to make a copy. Think about design often leads to insecurity, right? That's one example. Okay, what follows from that is you cannot MFA protect get session token. Tried, doesn't work. It's consistent. You cannot put an IAM permission boundary around the user. Doesn't work. You can't stop it. Anyone can call get session token and make a copy that reflects the privileges of that account or that key that is used. Let's switch to assume role, which is the other half of generating temporary tokens. Good news. You can restrict calls. This is post-authentication. You can put in place policies to say who can actually assume role. Good. You're all doing that. You keep doing that. You review it. Good news. And you can, as I said before, you can revoke active sessions for any temporary token that came from assume role. I cheated though. That's not really a prevention. That's a mitigation piece. But I couldn't have prevention be completely empty, right? Gotta give hope to you. You can get your money's worth. But in reality and seriousness, you gotta work with what you have, right? Any technique that sort of reduces the problem and risk, you take. And then you just be eyes open on the risk that remains. So let's summarize and try to, right? 15 minutes and 25. I'm on minute 25. We're gonna go a few extra bonus minutes. From an attacker's perspective, this is the way I look at temporary tokens. I would always use it immediately for backdoor access. It's another API call. It's true. It could be picked up by the defenders looking at CloudTrail. But I figure if you're gonna pick up my temporary tokens and you're smart enough, you're probably gonna be able to pick up my compromised token access in the first place. It's a risk I'd rather do because it buys me 36 hours. It obfuscates. You may not understand it. It's hard to detect. Your mitigation options are more limited. You may be surprised and you may be slower, right? I would combine it with other attacks. I would use it with pre-signed URLs. I would attack logs with it. I would set up lambdas and execute lambdas. I would actually use lambdas to try to keep generating temporary tokens. And clearly I would attack logs, because if I can erase all signs of me using temporary tokens, I'll win, because CloudTrail is really most of your visibility into what's happening. But let's switch to the defender side. Plan right now, review your playbooks is sort of the bottom line, especially how to mitigate, how to recover. Detect, you have options. Prevent, you may be limited, but figure out how you recover once you detect this. And so lockdown access keys by whitelisting IPs or VPCs, you can do that, right? If you can reduce compromised credentials in the first place, then the use of temporary credentials, proportionally, there'll be a lower risk or probability. You might isolate temporary tokens in a different account, because cross-account access can be controlled. That's not easy to do, but it's something to consider. You might separate or segregate user accounts. These users are real humans logging into the console, have no API keys. These users have only API keys. It's just a little bit easier to keep clean from a detection perspective and maybe lockdown perspective. These are just compartmentalizing, segregating things, trying to deal with it in a more organized fashion. Minimal privileges, of course, goes without saying. Review everything, especially assume role, pass role. Detection, you've got things to do. You should immediately be looking at get session token, because it's rare and it's probably suspicious. It's not very common unless you're doing MFA access to API calls and enforce that. Assume role, much, much harder. I don't know that you can easily do much with it. It's too noisy, false positives. You should detect, of course, usage of temporary tokens. ASIA, you should know that they're being used. Clearly harden your logging and alerting system, make sure it's configured right. And maybe use AWS config for additional config checks and also knowing about code changes and lambdas. Okay, mitigation. Look at your playbook, be prepared. If you have to deal with compromised temporary tokens, at least you've thought about it, right? Try not to use get session token, try to use assume role. Maybe don't use temporary tokens, just have permanent keys. These are not perfect solutions, because they have problems too. You can't create 1 million permanent accounts and permanent keys. That'll drive you crazy and you'll make mistakes. All right, revoke sessions for temporary credentials that came from assume role. Definitely do that. No matter what, create and test your recovery plan. Treat it like business continuity. How do I recover from this? Provisioning, you might look at CloudTrail, parse out temporary tokens, store them somewhere, so at least you always have an up-to-date list. That takes coding. It's not for everyone. You could make mistakes and introduce problems. Again, these are partial solutions, but it's worth considering. I'm trying to give you the checklist. All right, you might say never, this won't happen. I lock down compromised credentials. I also lock down escalation of privileges. This probability is way too low. And if you are in that state, truly, I applaud you, share with everyone else. I have my doubts. I have my doubts because we have very smart people out there on the pen test side, the red team side, Rhino Security I mentioned earlier. This is out of date. They're in the 20s, maybe 30s. Every time there's a new way to escalate privileges. I circled in red some interesting ones because there are other services. It's how to use EC2, Lambdas, DynamoDB to escalate privileges, right? It's not as simple as, oh, the permissions are wrong. It's a little more complicated. Just to make sure everyone's read the doc, there's doc, URL included, about services that work with IAM. Lots of colors here. You want to look at the second column from the right. It's temporary credentials. Does this service use temporary credentials? Green means yes, which is bad news. Green is bad in that second from right column. I circled a few interesting ones. Of course, EC2's there. Lambdas are there. AWS backup, because backing up storage is often not paid attention to versus direct access as an exploit. What else is in there? Oh, DynamoDB, that's on Rhino's list. Developer tools, CI/CD pipeline. If that's compromised, stuff is going to slip into production. They all use temporary credentials, which probably means they will assume role, but you allow assuming role, but you have to actually read this. What Corey said becomes your problem because you actually have to read about this stuff to understand your risk. IAM's there. WAF, that was in the news a few weeks ago for a financial institution. A WAF role was involved in gaining access and escalating roles. Networking's common, that's why I circled it. Internet of Things, that may not be so common, but it's out there. You can buy a vacuum cleaner that uses AWS Internet of Things. It has temporary tokens, it assumes role. You can compromise a weak endpoint like a vacuum cleaner, you get a X509 cert somewhere there, you can make a call and get temporary tokens. You have to evaluate the risk if you built your own IoT. We didn't talk about EC2 instances. I'm just painting the picture that assumes role. What's pretty common there is someone gains access and maybe elevates privileges through EC2, gets temporary tokens, and it's a HTTP GET or curl call away to get those access keys, the temporary tokens. But it doesn't have to be authenticated access. We still have network access to EC2, port scanning, SSH, WordPress, Apache, whatever you're running, can have vulnerabilities, CVEs, people get to root, and they can, same thing, get temporary tokens. We're almost at the end. I want to point out and sort of provide kudos. Netflix is one of the folks, along with others that share. They looked at the EC2 compromise of temporary credentials and said, great, we're going to solve this by IP whitelisting. So if someone grabs those temporary credentials, copies it to another host, they won't be able to use them. They wanted to solve half the problem, but that's half more than they had before. They also used a metadata proxy, which is how you get temporary tokens from an EC2 instance. And that's how they insert a policy dynamically to using the IP address of the EC2 instance. You can only use those tokens from that EC2 instance, which is the other half of the problem that they admit they're not solving. As an attacker, your best bet is get temporary tokens from EC2 and use it from the same host. That's the flip of more traditional thinking. More traditional thinking is grab your passwords, leave, because you're worried about leaving a trail. In the cloud, grab the password, and if they're smart, they've used IP whitelisting and stay on the host because their logging is probably weaker than their host monitoring. So think about that. That's interesting. So what's the big deal? I mean, does this just boil down to just do better at security and temporary keys are sort of like permanent keys? No, because ultimately, assume role is there, whether you like it or not. Everything uses it. Any user can create temporary tokens, the get session token call. And my analogy is, if for the folks with Unix experiences, what if the sudo command, which gives you elevated privileges, gave you a temporary username and password? That's sort of the analogy here. I don't know about you, that makes me queasy. You have to think through the implications of that versus what it does today. Either way, your surface area is higher and exposed. And from a defender perspective, it just comes down to, you can manage it, but it's complicated. And complication and distraction is the last thing you need because you'll make mistakes. From an attacking perspective, it's complicated, it's distracting, and that's the opportunity for the attackers, right? And the last slide I'll leave with you, which is just thoughts in progress, is I just went through a bunch of slides. Even if you absorbed it, the worst thing is to treat this as a checklist because the checklist is incomplete. How do we make use of this tomorrow, a week from now, a year from now? I think there's got to be a more systematic approach to thinking about this. So this is my first stab that I'm just playing with. And I took an attack chain from MITRE, and that's the top row, which is their tactics. And I tried to boil down the scenario into some of the API calls that were used. Assume role, get session token. And then at the bottom half, I tried to think from a defender's perspective, what can I do to prevent, detect, and mitigate each step of the chain as well as the whole chain? Some things like get session token, I can isolate and say, that's bad. Whenever I see it, it's bad. I'm going to detect, I'm going to prevent, I'm going to try to do something. Other things are harder, and you have to look at more behavioral anomaly detection. So this doesn't solve the problem, but maybe it helps us remember and think about it to do gap analysis. Maybe you can fill in the chart, pass it around, and discuss. Anyone see holes here? Can we do better detecting or preventing? Did AWS change something that allows us to detect this or that? Just a framework, a planning tool, right? But because if we can't get to here, it's going to be really hard because you can't trust a checklist that's very tactical, right? You don't understand conceptually what the principles are. So with that, I've run over time. You've all been really patient. Thank you. Depending on time, I think we're at a break, but I'll be happy to stay around here or outside for questions. Slide deck can be had there. I know they're doing videos, which will be posted shortly or later on YouTube. So thank you.